Okay, so today we will discuss the mesh current methods when dependent sources are there in the circuits. So, as I told you in the context of node voltage method, again I will emphasize this that there is no difference between when analyzing the mesh current method, when you have the independent sources and when you have the dependent sources. So there is no issue. The only thing you have to consider is that the dependent sources depend on the some currents or voltages in the circuit. So you have to just consider that relation. So let's try one example, very simple example. So we have two voltage sources. These two are independent voltage sources, and one is dependent source. So this dependent source is basically current control, voltage control voltage source. So this is not V5 but V5. Okay, and V5 is the voltage across this 3 ohm resistance. So let's start writing the mesh current equations for this circuit. So we start with the labeling the essential nodes. So you see here we have essential node. This one essential node is this one because more than 3 circuit elements and 3 circuit elements are attached, and we have nodes. So number of essential nodes in this circuit we have 4. So essential nodes 4. Essential branches. So branch number 1, branch number 2, branch number 3, branch number 4, and branch number 5, and branch number 6. So we have number of essential branches 6 essential branches. So how many equations do we have? So number of equations BE minus NE minus 1, 6 minus 4 minus 1. So we have 3 equations. Okay. So we have 3 mesh here. So we just mark this mesh number 1 or loop number 1. We can mark this as loop number 2, and we have loop number 3. So we have 3 loops in this circuits, and we just assign some direction to the loop currents. So let's say this is current I1, this is current I2, and this is current I3. So this is just fictitious direction and fictitious currents. You can assign any direction you like, so it's not a big deal. If you remember in previous part of this lecture series, we already solved 2 different scenarios by changing the direction of the loop current, and the end result are the same, and it should be the same. Okay, so now start writing equations for loop number 1. Okay, so loop 1. So we have 25 volt is the voltage rise. 25 volt is the voltage rise. Now the current flowing through this 2 ohm resistance is I1 minus I2. So 2 times I1 minus I2, and here we have I1 minus I3 because these I1 and I3 they have opposite directions. So 5 times I1 minus I3, and what about this voltage? When just considering this current I1, so this voltage is supposed to drop. So it is the voltage drop here. So voltage rise is equal to the sum of the voltage drop in the circuit. Similarly, considering loop number 2, applying KVL to this loop. So we have now, considering the direction of I2, when I2 is moving like this, so this is supposedly a voltage rise. Okay, so we can write this as minus 3v5 is the voltage rise, and this will be equal to 14 times I2 and 2 times I2 minus I1, because I1 and I2 they have different directions. So I2 minus I1, and what about here? So 3 times I2 minus I3. Now look at loop number 3. So just by considering this direction, the current direction of the current I3, so this is the voltage rise. So 10 volt is the voltage rise, is equal to voltage drop in 5 ohm resistance. So 5 times I3 minus I1, 5 times I3 minus I1 plus 3 times I3 minus I2 and 1 times I3. So we have now 3 equations, and there are 3 unknowns: I1, I2 and I3. These are the unknowns. But we have another unknown, that is V5. So V5 is also unknown. So we have 3 equations and 4 unknowns. So this is the thing we have to consider while analyzing the circuits with dependent sources, voltage source or current source. Now look at the circuit. You will find V5 somewhere in the circuit. So you see here the voltage across 3 ohm resistance, or the voltage drop in 3 ohm resistance, is V5. So this V5 is equal to the current flowing in this direction through this 3 ohm resistance is I3 minus I2. So I3 minus I2 is the net current that is flowing through this 3 ohm resistance, multiplied by the value of the resistance, is equal to the voltage drop. So this is V5 is equal to 3 I3 minus I2. So now the story is very simple now. Okay, this unknown can be computed from this. So substituting this here. So now we write all these expressions in a simplified form. So look at this one. 2I1 and 5I1 is 7I1 minus 2I2 minus 5I3. Take this, transport this 10 ohm on the left side, so you will have 25 minus 10 is 35. 25 minus 10 is 15. So we can write this expression as 7I minus 2I2 and minus 5I3 is equal to 15. This is the simplified version of the first equation. Now, considering this one, substituting this value here. So, first, you have to substitute this 3I3 minus I2 is equal to, so this is 3 3s are 9, minus 9I3 and plus 9I2. So we can write this as minus 9I3 and plus 9I2. Okay. Now we have minus 2I1 plus 14 plus 2, 16 plus 3, 17. 17I2 minus 2I3 is equal to this thing. Transport this to the other hand side of the equation. So you will have the simplified version of the expression as, let me write this with black marker so that you can distinguish it. 2I1 plus 10I2 minus 6I3 is equal to 0. Okay, so this is the simplified version. You can do it a little bit, arithmetic is involved over here, so you can simply write the expression. Now come to equation number 3, the last equation. So the simplified version of this equation is minus 5I1, okay, minus 3I2 plus 5, 3, 8, 1, 10. So 10I3 is equal to 10. Okay, so now we have 3 equations and 3 unknowns. Okay, so transporting this into matrix form, so minus 7 minus 2 minus 5, 2, 10, minus 6, minus 5, minus 3, 10, I1, I2, I3, this thing. Okay, so after solving this expression for current I1, I2 and I3, so we have I1 is equal to, you can just verify by yourself. So I have I1 is equal to 4 ampere, I2 is equal to minus 1 ampere, and I3 is equal to 3 ampere. Okay. Now if you are asked that how much power is delivered by this dependent source, okay, so you can simply write this as power of the dependent source is equal to voltage multiplied by current. So minus 3 into V5. V5 is 3 times I3 minus I2. I3 minus I2, which is 4 multiplied by the current I2, and I2 is nothing but minus 1 ampere. So you will see here that you will have the voltage okay. So you will now have 36 watt is the power. Okay, so this is all how to solve a circuit when you have dependent voltage source. The same treatment can be done with current sources, just assuming the voltage across that, and then finally solve that for the values which are unknown in the controlling authority. For example, it is a voltage controlled voltage source, or current controlled voltage source, or a voltage controlled current source, or current controlled current source. So whatever the unknown, you can simply using the relation like this, which is in the circuit, and you can solve the circuit. Okay, so this is all. From here you can try some problems by yourself and